Assignment 1-5. I've written down most of the questions, so you're going to want to press pause in between each question so you can write it down so you're not just trying to go as quick as I am, because you're not going to. For these first questions is, can you just take the derivative using shortcuts? So these are not long questions, so we're just going to go quickly one to the next, press pause when you need to. I am sure you did these correctly. The derivative of 2, any constant, is 0. The power rule, 2x. The power rule, 3x squared. The derivative of 1 is 0. Again, I'm not going slow. The derivative here, the derivative of 1t, and the derivative of 2 is 0. 2 times negative 2, negative 4t, and negative 3. Again, press pause when you need to. 2 times negative a third, subtract 1 to the exponent, negative 2/5 x is just negative 2/5, and the derivative of any constant is 0. The derivative here is negative 6, and subtract 1 to the exponent. Then we have to find the derivative at 1. Now 1 to any exponent is 1, so negative 6 times 1 just gives you the answer, negative 6. Take the derivative, that's 2x minus 2, evaluate at 2, and you get 2 times 2, take away 2. I think that's 2. That's a lot of 2's. Number 9, take the derivative, then evaluate at 1, and you get the answer 3. The derivative of 2 is 0. 3 times negative 1, subtract 1 to the exponent, and then evaluate at 2. I only need the x value, and you get the answer negative 12. Number 11, I'm going to change this to x to the negative 1. The derivative is negative x to the negative 2. And that's it, right? There's no making sure, nothing to evaluate at. Perfect. I got this all written out super quick. For number 12, I just have to change the second one. So it says negative 4 to the x to the negative 2. No fractions. This is calculus friendly. The derivative is 2x. Negative times the negative is positive 8, and subtract 1 to the exponent. This one I get to multiply out. I got a FOIL. That will give me 4x squared minus 2x, and minus 2x is negative 4x, and then negative 1 squared is 1. If this is what you want to do that, and you'll get this answer. And the derivative of this is 8x minus 4. Again, I need to distribute. Then I can do the power rule, and I have my derivative. Simplify. X to the 1/2 over x to the 1, subtract, and you get x to the negative 1/2. Now the power rule, that's negative 1/2. Subtract 1, go negative 1, take away 2, negative 3 over 2. Number 16. Alright, let's make this look right. That's x to the 1/3. Make this look right. That's x. Now the numerator's 3. Square root gives me the denominator of 2. Take the derivative. That's 1/3. Subtract 1. 1 take away 3. For the second one, 3 over 2 times 1. 3 take away 2. That's positive 1/2. And you've taken the derivative. Number 17, we're going to write this as 2 fractions and simplify it. So this simplifies to t, and this simplifies to negative 2. The derivative of 1t is 1, and the derivative of negative 2 is 0. Write this calculus friendly. So it's x. It's 2 over 3, but it's negative because it's in the denominator. Now take the derivative. So negative 2/3 times 1. Subtract 1 to the exponent, negative 2, take away 3. And you've taken the derivative. Again, write this calculus friendly. That's 1/3 x to the negative 2. Negative 2 times a third. Subtract 1 to the exponent. Number 20. 3 squared is 9, and then x to the negative 2. Negative 2 times 1/9. Subtract 1 to the exponent. Number 21. So I'm going to write this as 3 fractions first. The square root of x is to x to the exponent 1/2. You're going to be subtracting so the square root of x is x to the half, and I wrote it as 3 fractions, so I can simplify each one by doing exponent rules. If the bases are the same and you're dividing, subtract. So that's 1/2 or 3/2. 1 take away half is a half. And then this one I'm simply going to write as x to the negative 1/2. So it has no fractions. So I have the algebra ability to get to here and now do the power rule. A negative times the negative is positive. Subtract. And you have your derivative. Oh, I forgot a half. So a negative times a negative, so that's positive 1/2, and then that. 22, we're going to multiply it out, distribute, first times first, outer, inner, last, and now we're going to do the power rule. 3 times 3, 2 times 21, and then minus 5x, and you've taken the derivative. 23, I got that. The derivative is 6x, and the second derivative would be 6. Again, press pause, write it down and set it up, and then press play. I'm going to write this as x to the 1/2 plus 2. The derivative of this is 1/2 x to the negative 1/2. The 2 is 0. And then the derivative at 4, plug 4 in. Just for fun, I'll simplify it. So 1/2 means the square root of 4. So the square root of 4 is 2. The negative exponent means reciprocal. And then multiply it together and you get a quarter. 25. Press pause. Set it up. Then do the work with me. We're going to write it calculus friendly, no fractions. The first derivative is 2 is 0. Negative 1 times negative 2 is positive 2. Subtract 1 to the exponent. The next derivative, negative 2 times 2 is negative 4. Subtract 1 to the exponent, and then plug in 2. That's the same as this. 2 to the exponent of 3 is 8. The negative exponent puts in the denominator, so that's a negative 1/2. 26. Multiply it out. The first derivative, that's what this symbol means, is 2x, subtract 2. The next derivative, take the derivative of this. The derivative of 2x is 2, and the derivative of negative 2 is 0. Again, press pause and write it down. The third derivative is this. The next derivative is 2, and the derivative of 2 is 0. Press pause. Write it down. The derivative of this, that's all it's asking, is 3x squared. Press pause. So I want to find the second derivative, but I got to do the first derivative first. So that's 3 plus x to the negative 2. Then take the derivative of this up here. So the derivative of 3 is 0, and this is negative 2x to the negative 3, or negative 2 over x cubed. Number 30, write it down, press pause. I'm going to write this as 3 fractions. And then I'm going to simplify it. So x squared over 2x leaves me with 1/2 x. 4x divided by 2x leaves me with negative 2. And then 6 divided by 2 is 3, but we have an x in the denominator, so I'm going to write that as x to the negative 1. Now I'm going to take the derivative of this. So the derivative of 1/2 x is 1/2. The derivative of negative 2 is 0. And the derivative of the last term, a negative times a negative, is positive 3, and subtract 1 to the exponent. Now I do it again. The second derivative, the derivative of 1/2 is 0. And then it's negative 2 times 3, which is negative 6, and subtract 1 to the exponent. Number 31. Press pause. For number 31, we're doing the tangent line, right? Make sure that we're doing it right. So this is what we're given, x and y. I need to know the derivative. So the derivative here is 2x, and then plug in the x value. So the slope is 4, and then all together the line would be y equals, the slope is 4, and then x minus 2 plus 3. Same thing here, press pause. So the x value is 1. Plug in 1 for x. 2 divided by 1 gives you a y value of 2. To find the slope, well, first of all, we're going to write this as 2x to the negative 1. And then the derivative of that is negative 2x to the negative 2. Plug 1 in. 1 to any exponent is 1. So the answer is just negative 2. And then the line would be y equals negative 2, x minus 1, plus 2. 33 asks for the normal with all the same stuff. So all I have to do for the normal is I need to do the opposite, which is positive, and the reciprocal. So opposite, reciprocal, everything else is the same. Again, press pause. Write down the next one, pause. Plug in 1 for x, you get 1 plus 3, take away 2. This derivative here is 2x minus 2. Plug 1 into here, and you get the answer 0. So a slope of 0, we can do this, or you could just know that it's a horizontal line, y equals 2, same answer. 35 says find the x values where there's a slope of 11. So we take the slope, means the derivative, that's 9x squared plus 2, make it equal to 11, and then solve for x. So we're going to subtract 2, divide by 9. When I square root, the answer is positive and negative. So at positive and negative 1, there's a slope of 11. 36, I'm going to take the derivative, press pause. Take the derivative, it says where there's horizontal tangent means the slope is 0, because that's the slope of a horizontal line. Solve this. So we're going to factor out a 2x. So one solution is 0. The other solution, I'm going to add 3 and divide by 2. When I take the square root here, it's positive and negative. You don't have to simplify. It's just positive and negative and the square root of 3/2. Done. 37. Find the points where there's a slope of negative 1/4. There we are. So that's first. Write it calculus friendly. Take the derivative. And then for 37, make it equal to negative 1/4. Now, a negative exponent means it's the reciprocal. So do you see negative 1 and negative 1? So just make the denominators equal to each other. Another short technique, and the answer is positive and negative 2. Oh, and it says find the points. So if that's the case, I need to take positive and negative 2 and plug them in here. So positive 2 gives me 1/2, and negative 2 gives me negative 1/2. So go back here to find the y values. 38, find the a rock. So that's f at 4 subtract f at 2 over 4 take away 2. So plug in 4. I'm kind of cheating here looking at the answer key. That's 188. Plug in 2. That's 20. And that gives you the answer 84. For 39, just take the derivative. That's 9x squared. Plug in 3. That's 9 times 9, which is 81. Again, press pause. Number 40. Find the a rock here. Again, plug in 4 and plug in 1. I don't feel like simplifying this much, so it's 4 over 6. Subtract 1 over 3 over 3. Done. And on a calculus AP exam, you would leave it like that. You would never simplify it. Number 41. To find the rate of change at a point is a derivative. In order to do this, I need to write this as 2 fractions and then simplify it. So x squared divided by x squared, and then subtract, and you get 1 subtract x to the negative 1. Take the derivative. The derivative of 1 is 0. So a negative times a negative is positive x to the negative 2. And then the derivative at 1 to any exponent, and the answer to 41 is 1. 42. Find the a rock of that. So that's f at 3, subtract f at 0 over 3 take away 0. Plug in 3, and you get the answer 47. Plug in 0, and you get 2. And then put it together. 47 take away 2 is 45, divided by 3 is 15. The IROC of that is you take the derivative, so that is 6x squared minus 3, and then you plug in 3 into here, and that's 954 take away 3, and you get 51. For number 43, it says, where is it not differentiable? So for here, it's where, and you can see a graph in the book, but at x equals 1, there's a sharp turn. That's the x value of the vertex, no derivative there. For 44, it's where it is, where there's a discontinuity. So factor, and we have a discontinuity at 0 and negative 1. These are discontinuities. You can't take the derivative at a discontinuity, so the denominator. Here, if you plug 0 on top and 0 on the bottom, there's a jump in the graph. So at x equals 0, there's a jump. Turn the page. For 46, x to the 2/3, it's a graph that looks like this. If you go back like 10 pages, there's a sharp cusp, a corner there at x equals 0. For 47, a cube root has a vertical tangent. So there's a vertical tangent at x equals 0. 48. First, you have to find x values where there's a discontinuity. So if I plug 1 into the top, I get 2. I plug 1 into the bottom, I also get 2. So for 40, I see no discontinuities. It is a continuous function. For b, differentiate it. So just each piece. So that's 6x minus 1. And that's 5. And then, again, if I plug 1 into the top and 1 in the bottom, it's differentiable everywhere, because you get the same answer. Plug 1 into the top and you get 2. Plug 1 into the bottom and you get 3. Different answer. There's a jump. So at x equals 1, there's a jump. That means it's not continuous. Take the derivative. already it doesn't matter that you get the same answer here. There is no derivative at a jump. So that means it's not differentiable. So even though you plug 1 into the top and get the same answer, because there's a jump, you can't take the derivative there. 50. Plug 1 into the top and you get 2. Plug 1 into the bottom and you get 2. So it's continuous. Take the derivative and you get 6x minus 1 and 4. If I plug into the top, I get 5. If I plug into the bottom, I get 4. Two different answers. So at x equals 1, it is not differentiable. There's a sharp corner or turn there. 51. Look off the graph. Where are the x values which the function is shown is not continuous? So it's not continuous at negative 2 and at positive 2. And then the next question is, where is it not differentiable? So at negative 2 and positive 2, you can't take the derivative, but also at 0, because there's a sharp corner or turn. So 0 is also included there because you can't take the derivative there. 50, we're almost done. 52. I'll use a limit definition to take the derivative. The limit as h approaches 0, h, use x plus h. Plug in the function. That's what we're taking the limit of. This is x squared plus 2xh plus h squared. Now we're going to simplify it. So 2x squared and negative 2x squared, negative 5 and 5. So 2 times 2 is 4xh. Factor out an h. 2 times h squared is 2h squared, but factor out an h and it's just 2h. Now they remove, plug in 0 for h, and you have your derivative, and the power rule gives me the same answer. 53. Take the derivative using the alternate version of the limit, so as x approaches 1. So we have the function, and then I subtract. When I plug 1 in here, I get 1 plus 2. And now I'm going to take the limit of that. That is what? Positive 3 and negative 1. You factor it. This removes. Plug 1 in, and you get your answer. That's another way to evaluate a limit at a value using limits. Last one, 54. Oh, I thought I'd get it before the bell rings. To evaluate this is a derivative, right? So how would you take the derivative knowing what you know? This is the function, right? In terms of all that. That's the actual function. What's the derivative of that? And that would be the answer at the end, because you know how to take the derivative. Mr. G Math over and out. I am proud of you for doing your work. Until next time.